Hello students, welcome to Meetu Maths classes. Today we are doing class 12 Ncert chapter 5, that is continuity and differentiability, and this is exercise 5.2 question number 6. Your question is differentiate cos x cube into sin square x raised to power 5 with respect to x. So first of all, our purpose is to differentiate this function. So let our function is fx is equals to cos of x cube into sin square x raised to power 5. You can observe that your function is in the form of product of two functions. So if we are going to differentiate this function with respect to x, we will apply product rule. So derivative of fx is equals to first function as it is, using product rule, first function as it is into derivative of second function is sin square x raised to power 5 plus second function as it is multiplied by derivative of first function, that is cos of x cube. Now let us take this as your first statement, and we are going to first calculate derivative of sin square x raised to power 5. So consider derivative of sin square x raised to power 5. So our function is something square. So the derivative will be derivative of something square. Derivative of x square is 2x. So derivative of sin x raised to power 5 का square is 2 into sin x raised to power 5, and in turn we are going to take derivative of sin x raised to power 5. Now derivative of sin x is cos x. So we can consider x raised to power 5 as x, and our derivative of sin x raised to power 5x is cos x raised to power 5x, and in turn we are going to take derivative of x raised to power 5, and derivative of x raised to power 5 is 5 into x raised to power 4. So 5 into x raised to power 4 into sin x raised to power 5 into cos of x raised to power 5. So your final answer will be 10 times x raised to power 4 into sin of x raised to power 5 into cos of x raised to power 5. Now let us take this as your second statement. Now we are going to take the derivative of cos x raised to power 3. So consider derivative of cos of x raised to power 3. Now derivative of cos x is minus sin x. So we can consider x cube as x. So derivative of cos x cube is minus sin of x cube, and in turn we are going to multiply with the derivative of x cube, and finally it is the derivative of x cube is 3x square multiplied by sin x cube. Now let us take this as third statement. Now combining 1, 2 and 3, we will get the derivative of fx is cos into x cube multiplied by derivative of x square x raised to power 5. Sin square x raised to power 5 is 10x raised to power 4 into sin x raised to power 5 into cos x raised to power 5 plus sin square x raised to power 5 as it is multiplied by the derivative of cos x cube, that is minus 3x square into sin x cube. So your final answer will be 10x raised to power 4 cos x cube into sin x raised to power 5 into cos x raised to power 5 plus minus 3x square into sin square x raised to power 5 multiplied by sin x raised to power 3, and this is your derivative of given function. Your question number 7 is differentiate 2 into square root of cot x square with respect to x. Now to differentiate this function, let your function fx is equals to 2 square root of cot x raised to power 2. Now we can write our function as 2 into cot x square raised to power half. Okay. Now we are going to differentiate this function with respect to x. We get derivative of fx is 2 is your coefficient. Derivative of x raised to power half. Derivative of x raised to power half is half into x raised to power half minus 1. That is 1 upon 2 square root of x. So derivative of something raised to power half is 1 upon 2 square root of cot x square, and in turn we are going to take derivative of cot x square. Now 2 will cancel out. We are left with square root of cot x square. Derivative of cot x. Derivative of cot x is minus cosec square x. So derivative of cot x square is minus cosec square x square, and in turn we are going to multiply by the derivative of x square, and derivative of x square is finally 2x. So your final answer will be cosec square x square divided by square root of cot x square. Now your next question is differentiate cos square root of x with respect to x. Now let our function fx is equals to cos square root of x. Now differentiate this function with respect to x. We get derivative of fx is equals to, your function can be read as cos of something, and derivative of cos x is minus sin x. So derivative of cos of root x is minus sin of root x, and in turn we are going to take derivative of root x. Now derivative of root x can be written as x raised to power half is half into x raised to power half minus 1, that is 1 upon 2 root x. So we are going to replace derivative of root x by 1 upon 2 root x, and this is the final derivative of your function. Now question number 9 is prove that the function fx is equals to modulus of x minus 1, where x belongs to real line, is not differentiable at x is equals to 1. So we are supposed to first define our function. So let our function fx is equals to modulus of x minus 1, and it is defined as to the left of 1. The function is defined as negative of this 1 minus x. At x is equals to 1, your function is defined as 0, and to the right of 1 your function is positive, so it will give you x minus 1. Now to show that it is not differentiable at x is equals to 1, we are going to first calculate left hand derivative. So left hand derivative of your function at 1 is limit h tends to 0 f of 1 minus f of 1 minus h upon h. Okay, and this is equals to limit h tends to 0, f of 1 is 0, f of 1 minus h to the left of 1, your function is defined as 1 minus x, x is 1 minus h. upon h, and 1 will cancel out and it will give you limit h tends to 0. This is 1 minus 1 plus h, so minus h upon h, and this is minus 1. Now we are also going to calculate right hand derivative at x is equals to 1, and that is defined as limit h tends to 0 f of 1 plus h minus f1 upon h. Now to the right of 1, your function definition is x minus 1. So x is 1 plus h minus 1. f1 is 0 and upon h. 1 will cancel out and you are left with h upon h, and limiting value will be 1. Since left hand derivative is not equals to right hand derivative, that will implies that your function fx is not differentiable at x is equals to 1. Now question number 10 is prove that the function fx is equals to greatest integer function of x defined in between 0 to 3 is not differentiable at x is equals to 1 and at x is equals to 2. Now first of all we are going to define our function fx, that is greatest integer function of x, in between 0 to 3. So when x is lying between 0 to 1, your function is defined as greatest integer function will give you 0. In between 1 to 2, your function is 1, and in between 2 to 3, your function definition is 2. Now at x is equals to 1, we are going to calculate left hand derivative at x is equals to 2, that is limit h tends to 0 f of 2 minus f of 2 minus h upon h. Now f of 2 is, when x is equals to 2, your function definition is 2, and to the left of 2, your function definition is 1. So 1 upon 0 will give you, by direct substitution, it will give you infinity. And right hand limit, the right hand derivative at x is equals to 2 is limit h tends to 0 f of 2 plus h minus f2 upon h, and to the right of 2, your function definition is 2, at 2, f2 is also 2 upon h, and 0 upon h will give you 0. So since left hand derivative at 2 is not equals to right hand derivative at 2, so your function fx is not differentiable at x is equals to 2. Now we are also going to check at x is equals to 1. So left hand derivative at x is equals to 1 is limit h tends to 0 f of 1 minus f of 1 minus h upon h, and that will give you f of 1 is 1 and f of 1 minus h will give you 0, and by direct substitution it will give you infinity. And right hand derivative at 1 is defined as limit h tends to 0 f of 1 plus h minus f of 1 upon h, and to the right of 1, your function is defined as 1 and f1 is also 1, so it will give you 0. Since left hand derivative at 1 and is not equals to right hand derivative at 1, So your function fx is not differentiable at x is equals to 1 also, and this is what we are supposed to prove.